Each year, Microsoft Research hosts hundreds of influential speakers from around the world, including leading scientists, renowned experts in technology, book authors, and leading academics, and makes videos of these lectures freely available.
Good afternoon. It's my pleasure to introduce the last session before the wrap-up, and I have two presenters. Krishna Kumar here, who's our primary presenter, is one of our all-star academic developer evangelists based in Chicago. Krishna has been leading some of our biggest efforts with computer science faculty around the country. Recently in the game development area, led a big effort around XNA, and then over the last year has been doing a lot of work with an elite group of technical experts at Microsoft around Azure and cloud computing, and also trying to figure out how we can take this and bring it to you as faculty. So Krishna has his degree from Northwestern University in medical informatics, right? And we have here as well Gautam Reddy, who is currently based in Texas, but relocating to Redmond here very soon. And Gautam has been very active as well, working with a range of our offerings for faculty and students, including MSDNAA, which he has helped make more effective in terms of delivery in the U.S. So it's my pleasure to turn over the program to Krishna. Thank you.
Oh, thank you. Do you want to go first with the... basically, before we get into the talk, just a quick reiteration of the fact that all of you by now should have received an email with the Azure training token thing. It basically is a username and password that you received that if you log into windows.azure.com, will get you access into Azure, right? The account, the key thing to note is it's good for a month and it's been pre-activated, which means it's going to expire May the 8th. It's a hard limit. It's going to expire on that date. So please feel free to go in and play with it before the 8th. Again, the key thing is there's no registration required. It's all set up, good to go. The goal of this basically is to sort of let you have a flavor of what Azure is. Try out Azure, see if it's right for you. Try and run a couple of small loads and see if that's kind of what it is. And then following the 1 month thing, you can actually get in touch with your regional representative to figure out what the transition strategy is going to look like. And the one other thing I wanted to mention is actually we're trying to scale this program out. So if you are interested in taking this to your students, right? So say you're teaching a class and you basically want all of your students, say you have 30, 40, 50 students, and you want to have them access Azure as well, the same thing can be done for that purpose as well. So you would just contact us, your local Microsoft regional rep, and say, hey, I need 30 tokens for this duration. The duration can be anything from 2 days to a month, actually. And you can say, I need 30 tokens for 1 week, starting this date, ending this date, and we can make it happen. We'll send you the 30 tokens, and you can use it in your classroom and divvy it up among your students. So Gautam's going to go a little bit more into this.
So the issue is we don't know what all your requirements are, right? There's a diverse set of requirements in this room, and there's also requirements from faculty who need it for research, and they're probably not in this room at this point. How do we get to learn what your specific needs are in terms of the different aspects of Azure? And when I say different aspects, you've been hearing about the compute hour issue, you've been hearing about the data storage issue, you've been hearing about the Dallas data access to you. So the current model of 1 month access is for you to kind of play with the Azure platform and figure out where your specific needs are. Are they more on the compute side, or are they more on the data side? There could be additional parameters that involve resources and cost on the Azure platform, right, that are not listed here. So that's your window of opportunity to kind of learn what your specific needs are. And the needs could be, in teaching where you need a lot of accounts, but very sparse resources for 50, 100 students. Or it could be, I have 4 grad students working. I only need a small number of accounts, but each of those accounts need to have, a depth of resources behind the account. I talked to a number of faculty last night just to get a flavor for, do we know what we want, right? And I didn't get a good answer, and I didn't expect to, but I just wanted to see if, where the current thinking was. So I asked, hey, given what you've seen this morning and the whole day, do you know what your requirements in terms of computation are, or in terms of data storage are, or in terms of the other stuff presented? And yeah, we didn't know, and neither did I know, nor did the faculty know. So we are at a point where we both need to learn, right? And I did get some requests where they said, hey, I have 4 grad students and I want 4 accounts where they would go and play with the Azure platform and tell me what the needs are. Fair enough. We can make that happen, just as Krishna introduced in the previous slide. And then the teaching aspect of it is there as well. And there was a faculty who said, I need 20 accounts for 2 weeks so I can give an introduction to my class, and they can submit 1 assignment within that 2 weeks, and I have time to grade it as well, right? So if I said, hey, given the information I have, if I tried to create a solution for Azure Access, you could go with the highest common denominator, just let you tell me, what all you need and make that account available to all of you, and that's obviously very resource intensive. And probably not the right way to solve the problem, right? Because we're not just thinking of the 200 faculty here. There's probably more who will view this video online and come to us with similar requests. Obviously, the least common denominator obviously will not satisfy the 149 attendees out of the 150, right? And then the mean also just doesn't make sense because there's just so many variables involved. So the way I was thinking about it after the conversation last night is use the 30-day account to kind of figure out what your specific needs are, and then contact your Microsoft representative, whoever invited you to this conference, and we will kind of figure out where the demand is, and go to the product group and say, hey, it's the computation aspect that needs more number of accounts, or it's the data storage requirement that needs a smaller number of accounts but more resources behind it, right? Longer storage availability, or whatever that combination is. So that's my plea to you is don't store away the 30-day trial account. Just play with it to its maximum and get back to us with your specific requirements. It will help us a lot. Thank you. Actually, I think we are happy to take a couple of questions at this point, just because we'll transition into a different mode.
Are there any questions that you have about the 30-day? Yeah.
Well, I think that for students, we don't need accounts to the real Azure, but probably we need some virtual machines ready with a test environment. So with Visual Studio Express, SQL, and
Right.
and the SDK ready, because it's difficult to relate to our departments and say, yes, prepare the machine with all the installed stuff. This for students. For research, probably the biggest problem is that if we start thinking in cloud, we don't know how much computation needs. So before there was the problem, are we consuming too much? We don't know.
Right.
So we don't know if 30 days is enough to test and stress the application, because in university it's typical. We are not in a company, so the time is longer, delayed. So I think that this is the biggest problem. Students know. I don't think that if we are teaching, that it's better not to go to staging or on probably a try for one instance of application for a longer time, 90 days. I don't know. Probably there will be a first year, I think, in which we understand, and the next step we will learn how to relate to Windows Azure and say, okay, I need this capacity. I don't know also if I go to my accounting and say, oh yeah, I need 1,000 euros, 1 million euros to buy CPU. I don't know. I don't know. This.
Yeah, I'd say, we're all learning. So I had to pick a number, or as a company, we had to pick a number, and 30 seemed, as valid as any other number, and seemed acceptable both internal in the company to give it out. So you're absolutely right. There's no, data behind the 30-day number.
There was a question there.
Yeah, I actually just wanted to support that view. I think in 1 month, from my experience with student work, it's impossible to get anything done, especially if it's a new platform that you don't know. So I would really think 3 months is a minimum. If you guys want some really serious feedback that's useful for you, then this needs to be longer. Okay.
Yeah. So one of the things I'd probably make a comment right now is, if it comes to the end of the month and if you need an extension on it, please feel free to reach out to us. And if you do not know who your local rep is, ideally they're the ones to reach out to. But in the next slide, my email is going to be there as well. So please make sure to let us know, and we'll work out a way to keep you on it. Yeah.
Hi, I'm not sure if you covered this already, but is there a way to track the usage within those 30 days? So when faculty start to test out with those tokens, they could get some sense of the usage, or if they're driving or executing some kind of calculation over there, what that could mean in costs.
Right, absolutely. So from your perspective, the token that was given to you, and we can try it out. I was actually planning to go into it and use one of those test tokens for the demo, but I doubt that you'll be able to get access to the administrative or to view the billing console. What we could do absolutely is, if you at the end of the month came back and said, hey, this is my email that you gave to me, and I want you to tell me what my usage was, we'll be able to look it up. The folks that set it up will be able to look it up and get back to you. Absolutely. To get
those experiences that people don't have at the moment.
Exactly. To at least find a baseline.
Without those, caring about the cost.
Exactly. Absolutely. There's a question here, Kent.
Are there any, for the token, the 30-day token, are there any features that are not enabled?
No, this is the actual account that you would get even if you went on Azure and bought it. So it's not a light version, it's the actual deal.
Two things. One is that I talked to an Italian MVP, and he told me, oh no, Azure costs too much. Without any information, no one knows, and what does it mean it costs too much? Because you pick out of a credit card and whatever. So pay attention that all the community that wants to try but have fear without any foundation, so you can limit the usage of Azure. Another thing that probably I thought that it could be get out is that when we have to choose, there is no portability between the cloud platform. It's not a carrier I go with Verizon or as a cell phone. No, right. If I develop on Azure, I develop on Azure. So I have to decide before. So there is, for a price, it's a problem because we decide on false information, false idea, false perception. But this is. They told me, this Italian told me, I am an MVP. I have no guest account. I don't know what I said.
Right. Yeah, valid. Okay. Okay, yeah, absolutely. So thanks for that. And so this is my title slide. But before we actually get started, just really quickly, I wanted to poll the audience. How many of you would you say are interested in it primarily from a teaching point of view? Oh, significant. Okay. And from a pure research point of view, perhaps? Okay. Not as significant. Okay. And the second question I had was, how many of you were here yesterday for Roger's session on Azure? Okay, a significant number. So this is going to help me level set, basically, because I don't want to replicate any of the stuff that he spoke about. So yeah, thank you for being here. This title of the talk is basically Azure Academic Pilot, but I sort of made the title a little cooler. So this is me. My name is Krishna Kumar, and this is my email address. And if it's not visible all the way to the back, it's krishna.kumar@microsoft.com. That's the site, and we'll talk about the site in a second. So this is the site that I'm going to keep referring back to over and over. In fact, the email that I sent you has a link to this site because I've posted some of the walkthroughs and some of the FAQs up on the site. So what I'm going to do is actually take this as an excuse and just go up to the site, because even if you do not stay for the length of the talk, I'd like for you to leave with, information on what's here, because this is the site that's going to act as sort of the community, if you will, for the things that we do for the rest of the year. So basically, azurepilot.com is the URL, and it's set up as a wiki, and you'll observe it's not set up on a Microsoft property. It's on its own, which allows us one huge benefit. It allows us to make it a wiki, right? Which means you can come in and make any changes you want on the site, add new topics you want on the site. So you can actually change the main content. You're not restricted just to the forums, right? So that's a huge benefit. So some of the things that we've tried to cover in this site, basically, the key thing that we've tried to cover is the on-ramp, right? I mean, so how do you go from 0 to 60 on Azure? If you're starting to teach cloud computing, or if you're starting to incorporate cloud computing into your teaching, where do you go? How do you do? And if you just go on the net and search, you'll just find this vast array of information. So we've tried to take some of that and streamline it from an academic perspective, right? We've taken the most relevant bits, or we've morphed some of the bits into, usable nuggets of information in the context of an existing classroom. So things like, so just to walk through it, I'm going to take like a couple of minutes. If you start, basically is an introduction, starts with an introduction to cloud computing, talks about the kinds of clouds, models of cloud computing and all of that, and sort of walks through some of the steps, right? So what are some of the technologies that enable cloud computing to happen, right? So things like, physical design, so data center design, for instance, right? That's kind of important. Virtualization is sort of a building block of cloud computing, so we talk a little bit about that. Talk a little bit about the different protocol standards and wire formats, right? I mean, this cloud computing, as you know, is so fundamentally different from the way we write existing applications, right? No longer are you talking to a database down the wire or down the network. You're basically talking to something that's across the internet. And now the internet has this, property that will only allow HTTP on it, and most firewalls on the internet are going to block anything that's not HTTP and that's not XML. So we've completely had to redesign some of the ways in which we access data, and so some of those concepts are examined over here. We sort of move into a big overview of what the Windows Azure platform is, because up until now it was all agnostic, could apply to cloud computing in general. But we sort of drill down a little bit here into Windows Azure. We talk a little bit about the different components of Azure. And at this point, if you're getting started, we actually talk you through the kinds of tools you need, right? The tool set. You need Visual Studio, but what else do you need on top of Visual Studio? So we have a sort of a screenshot-based walkthrough. The reason we've tried to make it so clear is one of the feedback that we got from the early adopters was that they would actually pass off some of these responsibilities, the course prep responsibilities, to their students, right? Grad students or or even senior undergrads. So we've tried to sort of look at it from a student perspective and say, okay, if a grad student came in, right, or a senior came in and said, I got to prep this, at that level, it still needs to be accessible, right? So that's some of the things that we've had in our heads as we've gone about doing it. And just really quickly, we talk about compute, storage on Azure, storage using SQL Azure. So at this point, you'll actually see we'll start bringing in videos, right, from some of the industry events. So here's actually a video from Mix that got launched. So we basically, the key goal is we've tried to collate most of the information that's already out there, sort of pick the best, the most accessible pieces of content and throw it up on here so that you don't have to go about doing it. So I would sort of use this as a first place to start as you're thinking about the cloud. And finally, I'm going to take you to the references. Oh, actually, I also want to show you the events and workshops. So any major cloud event that happens will get listed here. So in fact, this event is listed here, as well as some of the other events we've done at SIGSI, at AMSIS, right? So you'll find collateral from cloud events at those locations posted up here as well. And finally, the reference, as the name suggests, will basically point you to things like the training kit, which is pretty phenomenal. I'm going to show you the training kit next. Things like virtual labs. I mean, somebody just brought up the concept of virtual labs, how awesome it is to be able to point a student at it, give them a hands-on lab walkthrough and say, go at it, right? Really nothing you can break. At the end of the hour and a half, it gets reset back. So it's phenomenal. So we've got virtual labs. Would love your ideas on what kinds of labs make sense for you and your students, right? We can actually add on to this or create a separate section of labs. So we'd love some feedback on that. Some case study, if you're looking at it from a business perspective, we've got some pricing information, TCO, all of that. The way to get in touch with us, obviously, you can become a member. You can make changes onto the site directly. There are forums on it. But if you actually want to physically get in touch with somebody, on the front page, we have this alias azurefac@microsoft.com. It basically comes into me and a few other folks in my team who are involved with the cloud effort. So there's a point directly into Microsoft through the site as well. So with that, I'm going to quickly show you why you should consider. The first thing you should obviously do is get the Azure bits. And the next thing you should obviously do is get the Azure Platform Training Kit. The link to that is on the site. And here's the reason why you should get it. It's basically about 160 meg download, but you basically get so much good stuff. You get hands-on labs on everything from starting with Windows Azure, all the way to SQL Azure, to Dallas, the session we saw this morning, to App Fabric. So literally every component of Azure, you have a hands-on lab. These are pretty cool, actually. You get, you get code in both C# and VB. The lab manual is pretty good. In fact, I'm going to show you one lab manual. I'm not going to belabor you by going into every one, but literally you get, pretty prescriptive, screenshot-based. Here's how you go. Here's what you enter. Here's what you do. So you can actually feel comfortable handing it off directly to your student without having to, make this more accessible, because that's a goal we've tried to go with. And again, if you have specific topics that you want us to incorporate or build labs for, we'd love to hear from you. We've got demos, samples, presentations. So these are, PowerPoint presentations, videos of these presentations as well, and some other resources. So with that, I'm going to jump back into my slide deck. So this site is a great landing page for a whole bunch of your efforts. And so up until now, it was pretty closed, actually. We were working with a few universities and a few faculty in the country. And a lot of the content here is based on their direct feedback. We'd love to make it more open now and get you to come in and contribute as well. Okay, so what I'm going to do is really quickly, so we've been talking cloud. I'm not going to try and define cloud and this and that, but just so we're on a level footing, and you'll see me whizzing through a whole bunch of slides. If you want me to stop, just please don't hesitate to tell me to stop. The key thing is there are so many players today that it's kind of difficult to often distinguish between the kinds of offerings. And so just for purposes of our session, we're going to agree upon these levels of distinction, right? You've got different types of clouds, completely public clouds like Amazon, Azure, Google is at the moment. You can make private clouds happen. A lot of vendors, Eucalyptus, and you'll see Azure actually starting to offer a private cloud solution sometime in the near future. Right, so you can have private clouds, you can have hybrid clouds bridging the both, which I think is really phenomenal. When we talk about a little bit about where Azure is headed, I'd love to talk to you about how we view the sort of the on-premise and cloud as not a binary state, as not you're either totally on-premise or totally on the cloud, but sort of as a continuum, right? In fact, I'm going to talk about it now because I think it's important enough that we sort of discuss it up front. In fact, a lot of the changes that you'll see happen in our APIs over this year, over the next year, is going to basically allow you to write a program once, and it sort of falls back into the way that Microsoft does APIs, right? At the end of the day, we're a platform company. So we try and make our platform such that it extends, right, seamlessly. So you'll actually see the client-side APIs evolve and the cloud-side APIs evolve so that ultimately they sort of meet in the center, if you will. And then you write your application once using that API, and your app will be able to straddle the client and the cloud, right? So dynamically, your code will be, so if you have an existing investment on-premise, your code will be running on-premise. Now, if your on-premise applications or on-premise infrastructure gets hit so much that you don't have capacity to satisfy the demand, then your code will automatically straddle over to the cloud and do what is called cloud bursting. So a portion of it will run here, a portion of it will run there, without really the code having to know where it is running. So a lot of interesting issues come up during those things. What do you do with co-location of data and stuff like that? That's, again, some of the things we're working on right now, but a lot of really exciting things happening on the hybrid cloud front, and that's basically where we see the whole software plus services thing that you keep hearing from Microsoft. That's sort of the vision that we have in our minds. The next distinction, again, with the whole as a service offering, software platform and infrastructure as a service, right? So this is a slide I used to talk about. So this is basically your stack, right? If you will, from the very raw wire all the way abstracted to the application layer. And so over here, you basically see that with on-premise, you pretty much own. When I say own, you're responsible. Whereas infrastructure, you basically hand off the hardware stuff over to a vendor. You get a box in the sky, but then anything on top of that box is your problem, right? So the operating system, patching, databases, infrastructure software, and then application, all of that's your problem. And finally, platform as a service is where you get a basic runtime on the cloud, and the only thing you worry about is the application, right? So Azure is a platform as a service play. Vendors like Amazon provide infrastructure as a service. And you'll actually see later this year, in fact, and it's been public, many executives have spoken about it. One of the plays in the Azure platform is going to be where we'll allow you to create an image of a VM image, if you will, and upload that into the sky, right? Upload that into Azure. So you can actually take a base Windows Server 2008 image, install all of the applications and programs you need on it, and then throw it up in the sky, and we'll manage it exactly as we manage our stock images right now. So with Windows Azure, just a quick bit of sort of insight into what went on into building Azure, right? Basically, we contacted a whole bunch of teams, primarily Bing, and in fact, if you ever get to, a lot of it's not public, but if you get to see some of the way that the Bing team has their infrastructure thrown about together, you'll find a lot of similarities between Bing and Azure. So this just talks to the scale of some of the things. I think it's a slide from my customer, the enterprisey deck, which basically says the expertise and experience we have. But I'm going to jump to this real quick. So this is Azure, right? I mean, I basically am going to call this Azure right here, and then everything on top of it as building blocks. Basically, this is here to show the whole platform as a service. So I'm not going to talk about infrastructure as a service at this point, but I'm going to talk about platform as a service, and then software as a service, and then the highest order bit, application as a service. Today, we'll mainly spend our time talking about, or looking at, actually, not talking about. I think we've done a lot of that. Looking at Windows Azure, and just briefly looking at the two component bits of Windows Azure, which is SQL Azure and .NET services. On top of these, so all of these products that you see here, Exchange, SharePoint, OCS, all of these products actually leverage Windows Azure. In fact, in a recent talk by Steve Ballmer at University of Washington, he mentioned that 70% of our dev team is today directly working on a cloud-based product, or tangentially their product is related to the cloud in some way, shape, or form. In a couple of years, it's going to be 90%. So it just basically shows you or talks about the fact that a lot of these, you will actually see a whole bunch of different technologies get integrated at the very top. But all of the products that you see here directly leverage Windows Azure. And the point I'm trying to convey through this is it's not something that we've created as a proof of concept and thrown it out there. We run some of our most intensive applications on top of this very same infrastructure that your code will be running on, right? So it's tried and tested. In fact, we'll talk about the Azure controller, the Fabric controller in a bit. The Fabric controller itself runs on Azure. So it's sort of a recursive thing, if you will, where the thing that administers Azure itself runs on Azure, but on a different cluster. So it's very performant and reliable. So typically, and this doesn't really translate really well onto the screen here, but typically, in an enterprise scenario, people talk about cloud for a whole bunch of issues where the key problem is, provisioning for peak, right? I mean, basically, if you have a sort of a Facebook-like scenario where your demand curve just grows up exponentially, you really do not want to, on day one, provision for your peak load. You want to basically start off small, ideally, and then grow as your demand grows. And cloud is awesome for that, right? That's your traditional scenario. But for this audience, I'm really, really excited about this opportunity, right? Big data. And this is basically what, and I was surprised to see every single keynote speaker here and every single session actually here addressed this concept of big data. And all of the examples that they gave are actually from the scientific community. So I'm going to take this opportunity and show some statistics from sort of the business community, if you will. So I'm going to let this sit for a few seconds. And then I'm just going to call out two things, maybe the last two, right? Walmart, the size of their database is in the order of petabytes, right? And this is basically growing. And an interesting statistic about this, right? I mean, we can talk about exabytes, and there's one more, zettabytes after exabytes all day long. But really, our capacity to fathom large numbers is pretty bad. So here's a way to make this apply in context. The amount of information that humanity created in the last 9 years is more than we have from the very beginning of humankind, right? So in the last 9 years, we've outstripped, all of the data that we've created in the last 3,000 years or so. And we will exceed that information, that content, over the next 3 to 4 years, right? So it's an exponential curve, and it's truly an exponential curve, because if you look at this chart, this is from The Economist, actually, from 2 or 3 issues back. The top curve is basically the curve showing the rate of growth of information or rate of creation of information, and the bottom curve is the rate of creation of actual devices that can store that information. And it doesn't take a statistician to figure out that we will create information that we will not be able to store, right? And which is really interesting. The way we address this issue now, because we're already at this issue, at 2007 thereabouts, we have surpassed that limit, right? So a lot of this information, we basically, we know that most of it's junk. We'll just basically sample it and throw it away. But in a lot of other cases, we really do not know what information is valuable, what's not. So we just randomly sample some data, hope that it's the right, from the right area that we want to sample, and then just throw the rest away. And really, to handle some of these issues, right, some of these issues and to deal with this issue, really cloud is the only way to do it. At the end of the day, that's what everybody's been saying. I'm not going to belabor the point. Really, cloud computing is, when people say, oh, it's a fad, we've seen it come, we've seen it go. Maybe, but unless you have something like the cloud, we will not be able to solve some of these problems, right? Not just in the scientific domain, but even in the business domain, right? So moving on, how does all of this come together? We've been talking.
Show the slide before, please.
This one?
No,
this one?
Yes.
Yeah,
just
sure. Oh, and all of this is going to be up on AzurePilot.com and also on the Cloud Futures site as well. So I'll make this complete slide deck available. This is where I get interested, right? How does it all work? How do I take it into the classroom? And as educators, how can you make it applicable to your students or into your curriculum, right? I look at it from a two-dimensional perspective. One is the infrastructural perspective, right? Because when you talk about cloud computing, you're talking about scaling infrastructure in ways that we have not in the past, right? Very few companies in the past ever had to worry about large amounts of data, large amounts of compute. So you had these, big 3-4 companies that would do it. But now with cloud, all of us have access to this kind of infrastructure, so it kind of pays to understand how this infrastructure gets put together. And so normally at this point, I have a video that talks about, how the new generation of, the 4th generation data centers are built. But again, people have spoken about it, so I'm not going to dwell on this. I'm going to talk about this actually, because interestingly enough, I didn't see a lot of content about it, and especially as it applies in a classroom setting, right? So again, like I said, fundamentally some things have changed in terms of how you write applications that run on the cloud versus traditional client-server applications that run on your network. So when you have an application that we totally and thoroughly understand how to run applications that run on one box, right? That abstract the resources on that one box, that do automatic memory management, mapping, virtual memory, totally beaten that to death, fantastic at it. Now, when you take that and you scale that across 1,000 nodes, now that becomes a very thorny, very interesting problem, right? How do you make sure that your application that's simultaneously running on 1,000 nodes is talking to the same piece of data, right? Especially if one of those nodes, it's the classic read-write problem, but now on an astronomical scale, right? How do you ensure there's one version of truth, right? Because when you have your databases replicated across, multiple nodes, how do you enforce that? How do you enforce fault tolerance, right? If your application is running a process that dies, how do you get applications to talk well across the internet, right? All of the protocols we've built, all of the stuff that we've done around, distributed computing, if you will, around, IPC calls, inter-procedure calls, and remote procedure calls, don't really scale across the internet. No binary data on the internet, right? So how do you take that? So yes, web services, if I'm doing this to a student audience, a grad student audience, somebody or the other is definitely bound to say, but we have web services. Web services are definitely good, but it's just a huge Band-Aid, right? So one of my biggest peeves about web services. Web services basically are designed to replicate RPC, remote procedure calls, on the internet, right? So basically, two problems with that. One is you have to have so much overhead data to replicate RPC, which in and of itself is not a problem. But the other thing is, all of web services communications happen using post calls on the internet. But guess what? On the internet, 98% of your traffic is GET, right? Most of the times, you're just retrieving images from the internet or retrieving stuff from the internet, so it's all GET calls. And all of your infrastructure is optimized for a GET, right? So you've got caching servers and gateways all designed for that. And really, web services do not take advantage of those. Whereas with some of the newer data formats and methodologies like REST, we can effectively take advantage of the way the internet is actually built. So some of the ways we actually do conventional things has drastically changed. And then there are new things that we've never had to worry about, like data-intensive computing. So there's just so much shift that's happening in the industry in terms of some of the common things that we do that is just phenomenal. It's scary and interesting at the same time, right? One of the best places to be. So what I'm going to do, yesterday those guys actually, Roger and Jared, spoke about Windows Azure in detail. So I'm not going to delve into each one. So what I'm going to do is just actually take 5 or 8 slides and just run through some of these, just for the benefit of folks that have not been in that session, or for the video folks that have not seen it yet. So Windows Azure, we're going to define it as a place to run your applications. You upload your applications and Windows Azure runs it. It's a cloud computing platform, so it's designed to scale. It does scale out, not scale up, which means if you need your application to be super high performant, we will take your app and run it on 1,000 nodes or something, right? That way it's more available, more scalable, instead of running your application on a really big, beefy machine, in which case you're pretty restricted in terms of how you can scale. Windows Azure is a utility computing platform, so you pay for what you use. Azure basically is built out on data centers, which has many, many servers, hundreds of thousands. And each of these servers is broken into virtual machines, right? So you'll actually see Azure, there are 4 instance sizes. 1 CPU, 2 CPU, 4 CPU, and 8 CPU, right? So typically the way we do it and the way we break it out is on every rack, you have a sort of a motherboard, and each of those motherboards is dual socket, right? So each socket has a quad-core CPU. It's typically Intel or AMD. So you've got one motherboard with 8 cores on it because you've got 2 sockets and quad-core processors in each socket. So you've got 8 cores on one motherboard, and that's why we offer a 1, 2, 4, 8 configuration. If you get 8 cores, you basically get the whole motherboard, and you get fractions thereof for a smaller size. So literally, the point I'm trying to make is each VM, at least at the moment, runs on its own core. So a lot of people basically are concerned about, oh, it's a VM, right? It's not the same VM as you run on your PC, right? It's a VM that's highly, highly optimized for that particular core, that particular hardware. So that's why your performance is going to be about 98% of native time. So this entire sea of VMs, we call it the fabric, right? We've just borrowed this lingo from distributed computing, grid computing. So we call it the fabric. And your application runs on the fabric, on a bunch of VMs. Windows Azure, like I said, does scale out. And to truly scale out, your compute needs to be, so obviously your applications need state, right? Because nothing runs in a vacuum, right? You basically need your application to have some persistence in data. So you basically need durable storage. So to get a totally scalable, stateless app, you basically need stateless compute and durable storage. And the way we do storage service, you know, the whole blobs, queues, and tables that they talked about yesterday, it's all an abstraction that's running on Azure itself. So it's interesting to think that Azure storage is just a compute service running on Azure. Right? I'm going to repeat it. So you've got a whole bunch of disks. So you've got a disk array of some sort, and you've got some servers that are abstracting those disks into blobs, queues, and tables. Those servers that are abstracting are running a program that runs on Windows Azure. So everything around Azure depends on Azure. So that's how reliant and reliable it is. So storage is just an application that's running on Windows Azure compute nodes, abstracting away a bunch of hard drives. Like we saw yesterday, we expose blobs, tables, and queues in storage. We make 3 copies of everything. And here's a super cool part. If one of your applications writes a bit of data into any of these storage mechanisms, when your call returns, you can be sure that all 3 replicas have been updated, right? So so in Amazon, for instance, and that's a design choice that they made, you get eventual consistency, right? If I update a piece of data, it'll eventually be consistent. That eventuality can be anywhere from a few milliseconds to a few seconds, right? Which means if I write a piece of data and immediately read it back, you may or may not get that same updated piece of information. Whereas with Azure, we actually do, what's the word I'm looking for? Right away consistency, if you will, right? So when the call returns, you can read the data back again. You'll get the exact same updated piece of data. All of it's accessible through a REST API, which means we don't care if you're running on Linux or Mac or Windows or using whatever programming language, you'll be able to access these services. So you can access these from desktop machines, on-premise infrastructure, or on the cloud. So it's completely open, completely interoperable. So I'm not going to get into a whole bunch of these details because we looked at some of these things. This is important. Management tasks are automated by the Fabric controller, right? Because you don't have people running around fixing machines and bringing up dead processes. So there's a piece of software. This software, like we saw, also runs on Azure, right? So the Fabric controller runs on Azure and manages the other nodes, hardware nodes and software processes. And The interesting thing is, for Azure to be able to, for the Fabric controller to be able to figure out that your application, whether it's running or not, and at what level of health it's running, you should tell the Fabric controller your application requirements. So you should say, well, my application needs to talk on port 80 to the external world, and maybe it talks on port 1450 to another process down the wire, and I need 5 instances of it. Right? And these are the requirements. It's almost like a system admin, right? When you give your app to an admin, you say, I need these requirements. And so basically you do the same with Azure, and you do that by means of a config file, which we'll look at. And once you provide that, it figures out how to do it. And this is what I'm talking about, actually. So you basically tell us what are the components. So you'll say, my solution has a web role and a worker role, and we'll see what that is in a second. Actually, I think we saw it yesterday, but still. And then you will tell Azure controller whether these talk to each other or do not talk, or do they accept input from the internet or don't they, and all of that. And Azure Fabric controller will open the right ports on the machine, and it'll close everything else, right? For security, we close everything that you explicitly do not ask for. And everything is load balanced. And all of this is scalable, of course. So you can say, give me 10 instances of my worker role, give me 2 instances of my web role, and all of that, and we'll load balance it across. You basically communicate between these guys, or we recommend that you communicate between these guys using a storage abstraction, typically a queue. You could communicate directly, but then that leads into the problem of if your first instance here is talking to the first instance here, it's made a call. What if that instance dies, right? It's just going to keep sitting, waiting for a response back. So you don't want that. We basically say, go loosely coupled, be asynchronous. So you can do both, though. Developer experience is key. We provide tight integration with Visual Studio, obviously, but we also integrate really well with Eclipse. And because all of this is just command line based SDK, it integrates with any IDE that can accept a command line compiler, right? Which is most of the IDEs out there. So we play really well with most of the IDEs out there, and we provide. When I say local debugging, Azure allows you, or when you install the Azure SDK, it installs a very high fidelity simulation of the cloud on your local desktop, right? So you're not building applications, throwing it up in the cloud to debug it. You can basically debug it locally because the underlying runtime is a very high fidelity representation of the Fabric controller in the cloud, right? And the runtime in the cloud. Geolocation, we have 6 data centers. Yeah, 6 data centers around the world, and your application can live in any of those 6 data centers or in multiple data centers. And here's a very quick illustration of the whole thing coming together, especially I'm going to stress on the Fabric controller, right? But basically, assume that this is Windows Azure Compute. This is Windows Azure Storage. All access to compute and storage is load balanced, right? So initially what's going to happen is you will send us your service. We'll take your service, and then your service will access your data. And again, observe that even if your service wants to talk to data, it's load balanced, right? So you get performance no matter if somebody externally is talking to your data or just local data access is happening. And then any access happens through the load balancer. The service model that we spoke about is where you have your actual service and you have some configuration file that you basically pass on to Azure, right? So what's going to happen is once you upload that into the web portal, which we'll see in just a few minutes, the model gets, the Fabric controller takes that model and then configures your Fabric as you request in the model. And if you say I need 3 services, it'll take 3 machines, 3 VMs, configure it exactly the way you wanted it to, open the right ports, and then push your service onto those 3 machines. And if you want to make any changes, before that, it's also going to take the physical IP addresses of these machines and replicate that to the DNS server. So when somebody goes to your service using the friendly URL that we set up, which we'll see, it knows to point them to the right IP addresses. If you want to make changes, you can go into the web portal API, or now there's a REST API that you can program directly against and say, hey, I need those 3 instances to become 8 instances, right? And boom, automatically the Fabric controller will take that change and make it happen. And then Once you need to shrink, the same thing, and it'll shrink. Now, the best part is if one of those nodes dies, right? When I say dies, it could be your service crashing, or it could be a hardware fault. The Fabric controller will detect it. Basically, what happens is every so often, the Fabric controller will send a heartbeat pulse to all of your running services, all of the running services, and if it doesn't receive a response, it'll conclude that the service has died. So it'll flag it as having died, and we still need to preserve your model. We need 3 instances of your service always up and running. So we'll bring up a 3rd instance, take down the old instance, and then update the DNS server to point to the new instance. So this is just to sum up everything. This is what your architecture will look like, right? Super simple. Any application that needs, or any piece of functionality that needs to be accessed from the internet gets implemented as a web role. So these could be ASP.NET projects, these could be PHP, any CGI project, right? Will have web server running beneath it, so you can actually access it from the internet. Any piece of code that does not require direct access from the internet runs as a worker role. So think of this as sort of a Windows service, if you will, and this is the front-end GUI, if you will, right? So this is just going to keep running in a tight, endless loop, crunching whatever it's crunching on. And we recommend that the way you communicate between these two is to use a storage abstraction underneath. So if you need to pass some data between this guy and this guy, store, and if it's a large amount of data, store it in a blob, and then pass a message over the queue or something like that. Both of these, though, can make outbound connections, right? Which is super cool because now they can actually talk to services on the internet, or if you've got some data that's too sensitive to upload to the cloud, they can actually call home, like call a service back at your on-premise location, grab the data, and then crunch it, So the fact that both of these can make outbound connections is pretty cool. Cloud storage is also accessible from outside, so you can actually use cloud storage directly from the internet. And the key thing to note is all of these, they don't have to, it's not an all-in-one package. You can only use cloud storage. You can only use compute, or you can use a combination of the both, right? So I can just store all my movies alone, maybe in cloud storage, and access that locally from my computer here. Or I could build an application that accesses that and shows me the movie or something like that. So you can decide at what level you want to play. I'm going to race through SQL Azure really quick. All I'm going to say is in Windows Azure storage, there's no concept of a relational database. The tables in Windows Azure is basically just an entity value pair. And the reason we designed it that way was because of scale, right? I mean, if you have a large number of relational databases, or a large relational database that's replicated, then it is very time consuming to make sure that the updates are transactional, right? Because now it's not just one table you're messing with, you're basically figuring out how is this related to all these other tables and propagating, and then you have to make 3 copies, you have to change 3 copies, and it's a nightmare in terms of response time. So Windows Azure storage is meant for really fast, really scalable applications, and so it is not relational. In fact, SQL Azure, when it was called SQL Services, was also not relational. This was just a beefier version of the Windows Azure table, but we had such overwhelming customer demand for a relational data structure that they completely went back to the drawing board and redesigned their specs. And so now you can sort of think of this as SQL Server in the cloud, but it doesn't expose the complete functionality of SQL Server. At this point, it's only going to offer the storage mechanism and the querying mechanism in the cloud. But again, this is very much a product in development, and so basically you will see a whole bunch of other functionality, analysis, BI, reporting, all of that. All of the stuff that you have in SQL Server on-premise today, you will see migrating over to this as well. So we looked at all of this. The best part is it uses the same protocol as SQL Server, which means the tools that used to work with SQL Server, your SQL Server Management Studio or LinkPad or whatever application that you use to work with on-premise SQL Server now works with SQL Server in the cloud. Your application can actually use one database or multiple databases, and the reason for this is we limit the size of a database today to 10 gig, the max size of a database to 10 gig. We will expand this limitation to about 50 gig or so in the near future, but the limit is because, again, beyond a certain point, it's prohibitively expensive in terms of replicating changes and making sure that it stays consistent. So that's the reason why the limitation exists. You can shard your database, obviously. You can break it into smaller subsets and throw it across multiple instances, and your application can access those instances in parallel or together. And the final bit of the Windows Azure story is something called .NET Services, and it provides two services, right? It provides access control on the cloud, so the traditional LDAP, Active Directory kinds of access control that we've, grown to use and love on premise gets now ported to the cloud, right? So your existing systems can hook up to this, and now you can get access control on the cloud, which is pretty cool. And then Service Bus, I'm going to actually talk about Service Bus in this slide right here. I'm going to show you this thing right here, which is a good example of the Service Bus. So Service Bus literally is just like the enterprise service bus, right? It's basically a service discovery and a service mediation process sitting in the cloud. So what do I mean when I say that? So say you've got two organizations, right? And this is very relevant when you've got multiple labs maybe wanting to talk to each other, share data, or like in the case mentioned yesterday, somebody has terabytes of data on their bench and they want to basically be able to share this data with somebody else instead of having to ship it over. So in cases like these where services from multiple organizations want to talk to each other but are confined by firewall boundaries, the service bus comes in and acts as a service broker, a mediator, right? So the service bus has two components: the registry, which is the part that basically lists this application and lists this application and allows them to discover each other, if you will. And once they've discovered, the service bus acts as sort of the mediator. So what's going to happen is this application will make a connection, a port 80 connection into the service bus, and the firewall is going to allow it because it trusts the service bus, which is being listed on a Microsoft.com domain, and it's a port 80 connection. So it's going to make it, it's going to let the connection go through. What the service bus is going to do is it's not going to close the connection. It'll keep the connection open, right? And the same thing happens from the other end as well. This guy does the exact same thing, and it'll keep the connection open here as well. And then these guys can talk to each other through this guy right there, because now you've got two connections that are open, port 80. Your firewalls are happy because it's on port 80, and so this guy is just going to act as a relay between those applications. So that's basically it. That's basically a really quick overview of not just Windows Azure, but the all-up Windows Azure platform, right? So what I want to really quickly jump into now is examine two things. Back in the slide deck we saw there are two kinds of scenarios where Azure makes sense. So one is your traditional kinds of scenarios where you need high-scale compute, and in the second case it was all about data, and you need internet-scale compute, basically with big, large volumes of data. So those are the two things I'm going to look at here. The first one is, let me just list all of these, and we'll look at these. So these are presently some of the things that we're seeing happening on Azure, right? So from just looking at some of the stuff that our customers are throwing up on the cloud, these are some of the things that we're seeing. You can use it obviously as high-scale hosting. So if you're building an application and you think that it's going to become big someday, it's a fantastic way to host your app and then scale with demand. So obviously you can host web apps or just throw up complete applications and have them run on the cloud. For media, it's great. For distributed, it's great. And it acts as a broker. So any sort of information sharing, integration kinds of stuff, it's great. What I'm really excited about, again, is the whole high performance angle of it. And over the next few slides, I'm going to jump over these case studies. All of these will be in the slide deck, and these are on the site as well. So you can actually see what each company did, how they used it, what the benefits were, and all of that. So and as you can see, some of these are really high profile users. There's others that we haven't added yet. Nike actually is one of the more recent users, and they've done some pretty cool things. But basically, this is a quick summary of the different components and how an existing end-tier application can incorporate these components into its makeup. So, and this is great from when I show this to software engineering faculty, they get really excited, right? Because now they say, oh, yeah, we talk about these different layers, and we talk about these components at this layer, and this shows them exactly what kind of things they can actually integrate from the cloud computing world at each specific layer. So as you can see at the very top, the presentation layer, obviously it's all about web roles, scaling up web roles. One level down at the services layer, it's again about web roles and worker roles. Again, on the connectivity, the middleware, if you will, the infrastructure, the bridge layer, it's all about using .NET services. And finally, storage is all about SQL Azure. So it's a direct one-to-one mapping, if you will, of some of these functionalities. So over the next 4 to 6 slides, actually, what I've done is we've listed out each of the big blocks of Windows Azure: web roles, web page, so ASP.NET web roles, services-based web roles, worker roles, the different kinds of storage abstractions, SQL Azure .NET services. So this, as you recognize now, is Windows Azure platform. This is your private cloud. So if you have an on-premise, infrastructure, that would be this, and all of the services running on it. And this would be the add-on services that are running on the cloud, things like identity and things like add-on services like Dallas and stuff like that, right? So for each of these kinds of applications, we just light up the appropriate kinds of blocks that get used and show you how they talk to each other, right? So I'm just going to jump through a bunch of these because I don't want to dwell. Maybe we'll stop at the HPC one a bit because, again, for this audience, that makes sense a little. But all of these are very detailed, and it's, again, going to be available as part of the slide deck. So Cloud Web, let's start with this, actually. Really quickly, let's see how this works. Cloud Web apps have a web browser or a mobile browser front end, or a Silverlight or a WPF front end. If you're a browser front end, you talk to an ASP.NET web role, which in turn ends up talking to a service role, which in turn will end up collecting data from your local storage mechanisms. And your web role can also talk directly to SQL Azure to gather profile data and app data, shopping cart and other mechanism, which this guy will access to directly. Ideally, I would not have these two arrows. I mean, I'm kind of a stickler for clean, separated layer of concerns. So I'm going to basically have this guy talk to this guy, which in turn will talk to this guy. But for optimization, you might have this happen directly. But anyway, so you get the idea. It basically shows you sort of the data flow, if you will, between different nodes. Composite, so instead of a complete application, and this is bits and pieces, I'm going to jump to, integration scenario, I'm going to jump to grid and parallel computing, actually. So in this case, you'll see that any application, maybe it's an enterprise application, maybe it's an e-science application, if it's trying to do something that's intensive, it'll probably talk to one web role, which will spawn a whole bunch of worker roles, and this guy will talk to the different worker roles through a queue mechanism, right, for scalability and loose coupling. And that's basically it. And then if you need some specific application data you want to talk about, if these guys need to access some data as part of the, which is probably constituting the domain knowledge, they can actually talk to SQL Azure, which can be accessed directly, or this can be synchronized with your private on-premise database as well. So gives you a really quick idea in terms of how we see some of these things being architected. Makes great sense in a software engineering kind of class to decide how to layer applications and how to throw them about together using some of these new taxonomies that the cloud offers. Okay, so that was basically, these are traditional application patterns, right? These are the really exciting bit. Internet scale, right? So far, most of us didn't have to worry about internet scale because there was no way for us to achieve internet scale. But now with cloud computing, we can look at internet scale apps, and this is just a few statistics from a Google paper as for their 2007 stats. Pretty massive, as you can imagine. Facebook from 2009. You can see the numbers again, pretty crazy. And again, most of these, Google or Facebook, any of these high-scale sites will actually, you'll actually see they simulate relationalism. They don't really use relational data. They actually use something like entity value tables and then try and connect them up together. So when you are worrying about, and this is, if I had only time for one slide, this is probably what I'd show, especially to, when I go in and talk to faculty and say, and they say, how can we incorporate, what do you think we should talk about when it comes to cloud computing? This is the one slide kind of thing, kind of deal where basically you said these are the kinds of ways in which traditional app development is different from a cloud app development. And these are the kinds of things you should talk about to your students when you're talking about what's the cloud? How do we do things differently in the cloud than we do today? So literally along all of these scales, these are the kinds of things. And this is, as you can imagine, a very small list, right? But we are using this as sort of a guiding, a start to basically guide us along in terms of what kinds of content do we need to create when it comes to the classroom, right? So we call these curriculum modules, actually. We're working with a bunch of faculty to try and create some curriculum modules to incorporate into the classroom. And so again, we use this as a starting point. But again, if there's any interest, if you're looking at the cloud and if you're already doing some of these things, please reach out to us. We'd love to see what you're doing and show you what we already have, if that'll help. And then also we'd love to take what you have and sort of help you scale that out much broader, right? So there are folks like me internationally who work with universities, and we'd love to help you scale out. So some of these things, and again, I don't know why the slide's replicated. So what I'm going to do now is, we have about 20 minutes, 25 minutes more, so I'm going to jump and actually do a quick walkthrough, right? Hopefully by now we really truly understand what cloud computing is, what Azure is, all the different moving bits in Azure. I just really want to take the rubber, make it meet the road, and show you really, here's some code. And I wasn't prepared to write some code, but given that we have the time, let's take a shot. What's the worst that's going to happen, right? It's not going to run. That's fine, right? So we'll actually walk through the cycle, right? We'll try and walk through a develop, deploy, and run cycle. And we've already seen the concept of roles, and so I'm going to jump through a bunch of these. So you know what? Let's actually just get to it. What I'm going to do now is, question, yes. I will repeat the question.
You showed for your the grid computing type of applications, you went through this web role, which then figured out how many worker roles it wanted.
Right.
But how do you do it? How would that sort of thing happen? You want this scalable web app, right? And maybe you need 5, maybe 50 instances running.
Right.
How can that figure out dynamically whether or not it needs to have 5 instances?
Exactly. That's a great question, right? So the question was, when you have a web role trying to scale out through a worker role, how can the web role figure out how many worker role instances it needs?
That one you can do. That one seems easy to me to do. It's how does a web role scale out?
How does a web role scale out? Right.
Because that's the front end.
Yep, absolutely. So there are multiple heuristics you can use. I'm going to throw the slide. I'm going to see. Actually, let's not worry about the slides. So there are multiple heuristics, right? Obviously, when it comes to getting the front-end web role to scale out, what we normally recommend is you have a monitor program running. It's basically every now and then polling the web role to see what the latency is. And then this program, if it detects that, wow, the web role is taking too long, will scale it out, will scale the web role out. The same program can actually help monitor the worker role as well. So it'll basically monitor the length of the queue and determine if it needs to scale up or down the worker role as well. Typically, we recommend that any scaling happen through an external program, because if your program that is trying to help scale is part of your overall solution, and if that crashes, then your whole scaling strategy is lost, right? Yes, you can have another instance that comes back up and picks up, but for the duration that this is down, and if that was the only instance, so the normal time to bring an instance up is about 5 to 10 minutes, right? So for those 5 to 10 minutes, you've lost your logic for scaling, and we recommend you don't do that. We recommend having a monitor application that's monitoring your web roles, your worker roles, the status of your queue, and sort of do the scaling. And it's separate from your main application, and so therefore, if it gets affected, then that's not going to see the effect, and vice versa.
So does the fabric give you those sort of performance metrics that you need?
Yes. So from the fabric, you can get a few metrics. You can basically So for instance, the queue, you can get the length of the queue from the fabric. In terms of I'm trying to think, the diagnostic, so there is a diagnostic pack, not a pack, but API that the fabric exposes, that you can get a whole bunch of information from the roles, right? Running role instances, you can query how many roles are running, how long have they been running, and what the CPU utilization on that VM is, and a bunch of those information. So basically, based on that, you'll have to come up with a heuristic that basically helps you scale. So yes, question, Katie.
You mentioned command line environment.
Yes.
Is it PowerShell based or it's?
So the command line environment for the SDK is just regular command line, but you can totally use PowerShell to access. In fact, all of the APIs can be accessed using PowerShell as well. So a lot of commandlets, we've created a whole bunch of commandlets that actually, use PowerShell scripts to do some of these things. Yes. Any other? Yes, sir.
I think it's your slide 46 that intrigued me.
Okay.
You mentioned that you can make applications belonging to different organizations to interoperate through your service bus.
Yes.
Okay. What does make the service bus trustworthy for the application, for the organization X and Y?
That's subjective. You have to trust Microsoft. Yes, I mean, it is, and that's, again, a valid question, because now if somebody else exposes, because you're literally able to see the traffic that's coming in. Yes, you could encrypt it, but still, I mean, you're able to deduce a few things about, the organization. So that's something, again, it's a sort of a trust relationship.
It's an open issue.
It's an open issue, absolutely. Yes.
On the previous question. Is there going to be something in Microsoft dealing with sharing of copyrighted data?
Sharing of copyrighted...
Assume organization X and Y are basically pirating movies.
Right.
You're going to transfer their data. And because you're a US-based company, you might have to provide the records of who transferred what. Did you think about this issue?
Yes. So the same issue applies to Dallas. The same issue applies to most of our storage services, for instance. So forget this. I mean, you throw up a pirated movie on blob storage, and you use that URL to illegally sell this to your clients, right? So at that point, I mean, the laws of the land come into play. Every country has jurisdictions on this data lives here, so we have these kinds of powers over who the owner of the data is and all of that. So have we thought about it? I'm sure we have. Have I thought about it? Not so much. But I'm sure that whatever the trademark, copyright, digital privacy laws of the land that are there will come into play. And that's, again, super important, because a lot of countries actually, I mean, Azure is only in 6 countries, right? The data centers hosting Azure in 6 countries. And that's interesting because certain countries do not want you to hold certain kinds of data outside their boundaries, right? So at that point, it's a question of, can we use cloud at all? And so, yes, at that point, it's a subjective thing. Do I want to go this route or not? Question?
I'm wondering if you have considered including in this Azure platform federal record management techniques and regulations.
Right. So have we considered including federal record management techniques and regulations? So I know that there is a part of the field team that's actually working closely with the federal government, the United States federal government, trying to figure out what their requirements are to try and see if we can bring that back into Azure. But we are also working on 2 other fronts. So we basically take a whole bunch of industry privacy and security standards, ISO. There's a bunch of 27001, I think. There's a few ISO certifications that you can basically get certified for privacy and security. So we are on those already, and we will work again when the whole concept of later, not in the immediate time scale, but later when we think about, do we want to go the private cloud option? At that point, you can basically customize the kinds of security and privacy regulations to which you want to be certified for. So at that point, you'll have full, discretion in terms of how you want to go. But we go with the most major industry ones right now. For any custom ones, we probably might not support it. Yeah. Yes, sir.
So what kind of logging information will I get as a user of Azure? I mean,
Yeah.
You showed how something was restarted, but maybe I want to know why.
Exactly. So the kinds of logging, so the question was about what kinds of logging information will be made available as part of Azure. So anything that you can log today on your Windows PC using Event Viewer, right, that you can watch using Event Viewer, the same thing will be up there. Because at the end of the day, what's running on Azure is Windows Server 2008. And you can turn on any of the metrics that you can turn on your local instance up on the cloud as well. So you might take a perf hit if something is extensively logging, but other than that, you can get anything. And you can have all of the data be saved in your table storage or blob storage and pull down the log and examine it. There are some third-party tools actually. Cloudera, I believe, is the name of the company. They build tools that actually connect directly to your instance and grab the logs directly and show you a pretty view of your running instance. So, yeah. Any other questions? Okay. So what I'm going to do quickly is, actually, let me see what I have remaining in my slide deck.
I have a question.
Yes.
What about the possibility for the universities to build their own version of an Azure
a private cloud
within their laboratories?
Absolutely. So at present, that's not something that's an option with Azure. There are other vendors out there that will sell you a stack that you can run on a cluster and make that a private cloud. Is Azure headed that way? Yes, absolutely. Eventually, and nobody, has a precise date in mind, but that's something we're absolutely looking at by way of taking, the whole Azure runtime, the Fabric controller, if you will, and making that available as a product, so you can take it and run it on your cluster, and it should basically be able to provide that environment on your local setup. And in fact, that's a direction that we are moving in as well, because the whole goal of having an application that seamlessly straddles the cloud and the on-premise setup will require something like that. So that's sort of the direction we're heading in. The timeline is the thing that's still TBD.
Okay. And what are the vendors that are involved with as far as you know?
Yeah, so the most prominent vendor is somebody called Eucalyptus, and I think they're open source as well. So Eucalyptus basically has a product now. I forget what the name of the product is, but
I suppose the other major vendors like Dell or HP.
Do they have? I know that they have a virtualization solution. I don't know if they have a cloud solution out of the box that runs on any cluster. But I could be, they might be doing something more recently that I'm not aware of. But yeah, from my last count, the most prominent one seemed to be Eucalyptus. But I know that these guys have cloud divisions. I don't know if they have the packaged software yet that allows you to do that. Okay, your question.
Yeah, a little follow-up here. So I see this presentation as a kind of invitation to participate in building applications for the cloud.
Right.
I would think that from the academic perspective, it would actually also be very interesting to learn a bit more about the internals, because you participate in the design. Let's say there are some interesting load balancing algorithms and all
right.
that. Is that something that you're also thinking of opening up? I mean, in some sense, that's also e-science, right? I mean,
right.
Analyzing all this data and looking what works best.
Exactly.
Underneath, and also if you teach, then you want to teach also the architecture of
the fabric controller, of the scaling logic.
How would you get involved in that?
Yeah, it's a great question. So the question was, I'm sure everybody kind of heard it, but basically, how can academia get involved in helping build Azure, especially get access to some of the internals of Azure? At this point, as I'm sure you already know, at this point there's no mechanism to do it. But that's very good feedback, actually. And in fact, for the Windows product, actually, that was something that Arcadis team helped spearhead, right? I mean, basically, you were able to get access to the Windows kernel for academics. So maybe down the road, that's something that we will work on. Obviously, there's a lot of interest. This is an emerging field, so that's something that. So he's the right guy to hear that feedback, and he's here, so that's good.
Okay, I think it's a great idea, and we will consider, I think.
Yeah, exactly. Okay. Okay, so I'm going to take the next, 10, 15 minutes, and really quickly show you end-to-end, right? So basically, everybody today received an email, and that email probably looks very similar to, okay, there it is. Looks probably really similar to this, right? You basically got an email ID and a password. So the Azure pilot site has a walkthrough, but I'm just going to actually walk through from that face on to throwing an application up on the cloud. So if you just go to windows.azure.com, this is basically our developer portal into Windows Azure. So at this point, you can go in and sign in with a live ID, and you would sign in with, in fact, let me see if I have it saved. There it is. So you would sign in with your Windows Azure _ whatever number, and if I remember the password, 402 maybe. Okay. Let's see if I can. You know what? Let's not worry about that. Let's just go in through a different account. But it's going to look exactly similar. And once you go in, you'll basically come into this page, My Projects, and I have 3 projects listed because I have 3 accounts on Azure, but you will see one project with the whatever Hotmail project, the name of your email was. And so when you click that, you will be able to see the different services inside that project, which for you should be empty. So the way you actually build a new service is just by clicking on New Service. There are 2 kinds of services. A storage account, which is basically an account to store data in either a blob or a queue or a table, and a hosted service. This is basically the kind of service that you would throw up your application into, and that would run that application. So how about we create, let's see, we've got, I don't know, 15 minutes. I think we can do both. So I'm going to create a hosted service first. And it's basically going to ask you for 2 things. It's asking for a service label, which could be anything. I could call it whatever, because it's going to be a private reference. Some description. So nobody outside of yourself will see it, because it's only going to show up on this page, not on the internet. But this thing right here, the URL that you choose here, is going to be seen on the internet. So we have this top level domain, and you can choose whatever sub-domain name that you want. And I'm going to see if I can get hello cloud, and I'm going to say check availability. And I think it's taken because it's not available. So let's get hello futures. Check availability. And, oh, you've selected. Oh, interesting. I've never seen this before, actually. You've selected a word or a phrase that's not allowed. I don't know why.
Take off the S.
Huh? Okay. Yeah, hello future. Okay.
The same.
Oh, it is the same. Interesting.
How about
Yeah, I just keep, okay. Okay, Amazon Premium. Interesting. I've never seen that. But here's, wait, what is this? No, this is a store. Okay, I'm going to say new service, hosted service. And you see how it says, okay, back. You see how it says 6 services remaining. This is a paid account, but you will see the exact same 6 services. And the 6 services means you can throw up 6 projects into your account, and you'll have about 5 storage accounts, right? So you can actually create 5 of these, and each storage account can store 100 TB. So you can actually store a total of 500 TB on this site. So I have not created a single storage account, so that's why I have all 6. So I'm going to say hello cloud and hit next. And let's just call it, I don't know, maybe Cloud Futures. Wow. Some allowed name. Okay, there it is. It is available. Good. And then, so the next step is basically, it asks you to choose an affinity group, and you have 2 options basically. You can say, so an affinity group, let's talk about what that is first. An affinity group is if you have multiple instances, right? If you have multiple roles, maybe you have a web role, you have a worker role, or you have some data projects. An affinity group allows you to bring them together, right? You can basically create an affinity group and bring all of those 3 projects under the same affinity group, which is going to tell us that you really care about performance between these 3 nodes, because you're probably accessing data, you're probably communicating. So at that point, we'll basically try and keep those as close to each other as possible. So if you did not care about that, you can just choose a region, which basically you see 9 listed here, anywhere Asia, Europe, or US, or you can choose East Asia, and as you can see, the different data centers here. So you know what, let's actually create an affinity group. And I say yes, and I'm waiting for this to light up, okay. And I have one affinity group already created, actually. So it's asking me if I want to create this as part of that affinity group as well. I'm going to say no, and I'm going to create a new one, and I'm going to call this hello, or actually Cloud Futures affinity group. I can again name this to be anything, and I can say give me North Central US. It's just north of Chicago, this data center. So I'm going to say provision me there, but again you can choose any of these different ones, and I'm going to say create. So what this is going to do is create a new account for me, and it is going to show me some information. At this point, it's just going to be blank. So let's wait, 10 seconds and see if it comes back. There it is. So it's telling me that I'm geographically at this location. This is the name of my affinity group. And right now, I have nothing deployed. And I can actually see that it provides me 2 environments, a production environment and a staging environment, and basically allows me to upload to either one of those. Now, there is functionally no difference between these 2. What would happen is if I uploaded into staging, for instance, it would basically return a URL that's some GUID, some super long number .cloudapp.net, and I can test that locally to make sure it works. Once I'm happy with the way it works, there'll be a swap button here. There'll be like a button that allows you to swap, and I just push that button, and that'll get promoted into production. And the app now will be accessible under some available name, .cloudapp.net. And internally, nothing's happening except the DNS servers are now pointing from this record to this record. That's all that's happening, right? So what we want to do is we want to throw up an application here. So let's actually fire up Visual Studio. I'm going to run as admin, actually. So when Visual Studio comes up, we'll be able to open up a cloud service project and throw that up there. So I'm going to say a new project. I'm going to actually minimize this toolbox. Okay, there's a cloud option, and I'm going to say cloud service for, actually let's call it hello, or actually cloud futures. I'm going to say okay. And what it's going to do is it's going to throw up a dialog now, and this dialog is asking me 2 things. Which language do I want to code in, VB or VC sharp or F sharp? And what kind of role do I want to create? Because when you create a application, you can actually create, like we said, a web role or a worker role. And then in terms of web roles, we can create an ASP.NET or an MVC or a WCF web role, or I can choose CGI web role and then create any application that's using any application that's fast CGI compliant. So Python, PHP, Perl, any of those. For now, let's just choose an ASP.NET web role. Let's call it Cloud Futures _ web to say that this is a web app. And what it's going to do is it's going to create the template. On the right, you basically see the application getting created. And the key thing that you'll observe is there are 2 projects, right? Here's your cloud project, and here's your Cloud Futures _ you know what, let me get rid of this to get some real estate. Okay, project creation successful. And you'll basically see that there's a cloud project and a cloud _ web project. And this is nothing but a regular good old ASP.NET application, right? You've got your default .aspx, you've got all of the things that make up an ASP.NET app, and it's all it is. If you basically, I'm not going to do it, but if I basically right-click this and say set as startup project, and I hit F5, it's going to open up, you know what? Let's just do it. So I hit F5, and it's basically going to open up in the ASP.NET development server. The key thing that makes this ASP.NET project into a cloud project, so you see how the ASP.NET development server fires up, and your blank page will load because there's really nothing, we've done nothing on the page. So I'm just going to close this. Let's do this. Let's actually get into design. Let's throw up some basic stuff. And I'm going to throw in, so we're doing a hello world kind of app, right? So I'm going to throw in a text box, maybe. Where's the text box? Text box. And let's throw in a button right next to it. And on the next line, let's throw in a label, maybe. Right, so this is your quintessential hello world, right? You basically type your name in, and you push the button, and it's going to say hello, whatever. So let's code it up. Let's double-click this. It's going to take me to the event handler. I'm going to say label1.text equals, not template control, .text equals textbox1.text. So after I accept my Developer of the Year award, I'm going to hit F5. And so you'll basically see that it fires up. It's going to launch the ASP.NET development server, and it's going to show us that page. And you see it's running on localhost, and it's running on this custom port, right? Because that's what ASP.NET Dev Server does. And I can say Krishna and click button, and it says, oh, it should have said hello, Krishna, actually. But yeah, don't take that award away from me, though. Okay, so I just proved it to you that this is basically just a good old regular ASP.NET project. But now something magical happens when you choose this guy, Cloud Futures, right-click it and make this the startup, right? So what happens now? Now this is now a cloud project. And what basically happens is it will read not just this. So basically you'll see under the cloud project, you'll see there's a roles node, and it says that there's one role, which is the Cloud Futures web role. And then there's two files, actually, the service configuration and the service definition. Remember when I said that when you throw up your solution into the cloud, you basically pass in the code and the config? This is your config file, right? So you can actually go in and mess with the XML directly. Or if you double-click this, we built a UI. Here's where you basically say, give me a VM size of small, medium, large, or extra large. Remember the 1 core, 2 core, 4 core, 8 core? That's this. This is where you say, give me 5 instances, right? Now we'll take this role and spawn 5 instances. Remember, where you basically say, give me an HTTP endpoint, and then you can go into different settings, and you can choose more endpoints. At this point, you can say, I want to open a TCP endpoint on this port. I want to call it this, and so on and so forth. So you can actually go make all of these changes, and these changes actually will get reflected right here. So this whole, the thing that we changed to 5 got reflected. So it'll round trip between the XML file and the IDE or the GUI. Now if I hit F5, something interesting happens. Now again, remember, I'm starting this as a cloud project, and so something called the development fabric and development storage will start up, right? So this basically is the local simulation environment of the fabric of the cloud on your desktop. So when it says development storage started, the next thing to start will be the dev fabric. And okay, we're still waiting for the fabric to start. Okay, there it is. It started. And now a browser is going to open up. So it's still waiting for the role instances to start. But this overhead is only for the first time. Now if I run this in the subsequent times, it's basically going to snap up like this because my dev fabric and dev storage have started. Okay, but the first time, I'm still waiting on the browser. Okay, launching browser, finally. Now the interesting thing here is you basically see it's running on localhost, but it's running on port 81, right? And I can basically say Krishna and push the button. It says, hello, Krishna. Same thing. You're like, okay, what's the big deal? Here's the big deal. If you right-click this and say show dev fabric UI, this will bring up an MMC, a Microsoft Management Console window, which actually will show you. So if you could log into the box that's running on the cloud, this is probably what you'd see. So you'll actually see some command window with just a whole bunch of debug spew in terms of what got loaded and all of that. And you actually see the 5 instances that we fired up, right? So you basically will see 0, 1, 2. All of these are the 5 instances that we fired up. Now, the way you would throw this up into the cloud is, let's actually stop this, Shift F5. I can right-click this, and just as I would package, I've got, what, 3 minutes? Kent?
Yeah.
Okay. Just as I would package an ASP.NET project, I would basically right-click and publish, and what it's going to do is it's going to compile the project up, create a single zip file, if you will. It basically actually does use zip, but it's going to encrypt it, so you won't be able to open it using WinZip. But creates a zip file, and then it's going to open up the location where it's stored the package file and where it's stored the configuration file. It's also going to open up the Azure Dev portal because it knows that the next step is to actually upload it. So at this point, it does not take your authentication information and throw it up directly, but that's something that, again, I think we'll see in the not too distant future. But basically, all you would do is basically come into this screen, click deploy, and in the screen that comes up, it'll ask you for a package file, which I can browse, and I know it's here, so I'm going to grab the location of this, come in here, choose the package file, and then it'll also ask for a configuration file. Let's minimize this. It'll ask for a configuration file from the same folder. I can choose a label for deployment, beta 1 maybe, and hit deploy. And that's basically it. And this will take a good solid 5 minutes actually. You'll see it pass through different stages. So when it says processing, please wait, the files are actually getting uploaded. And once the files are uploaded, it'll come into this next screen, where at this point, this is the super cool part, right? The Fabric controller is reading the config file, and it sees that I need 5 instances. I'm gonna close Outlook. And it basically sees that it sees 5 instances, and it's going to do a graph mapping, right? It basically understands all of the nodes that it has. It basically has it represented as a graph, and it's trying to see where it can take my project and locate it at which point in the graph. So that's basically what it's doing now. It's trying to identify the nodes, and it's basically, once it's done identifying, it's basically going to show you here. So this screen means it's identified the nodes, it's reserved that DNS name, and this is the website URL that we're going to get. And at this point, the website URL is, the condition of this role is stopped. So what you would have to do is basically hit run. And this process takes about 5 minutes or so. And we'll just have enough time to see what happens. I'm going to show you what happens because I think it's pretty cool. So this is what under the covers Azure, sort of a block diagram, if you will, looks like, right? Basically, you've got your hardware, you've got your hypervisor running on top of the hardware, and you've got these little virtualized instances. You've got 4 virtualized instances per chip, and the first virtualized VM is basically your server OS, right? This guy administers all of the remaining 3 VMs, and literally what's happening right now is when I say start running, the CPU has to get prepped. And the way basically it happens is a maintenance OS gets pulled in from the wire. This is about 50 meg or so. All it's going to do is format this partition, the first partition on the CPU, and download your server core VHD, your virtual hard drive on it. And any patches are going to be updated. And the best part is this process takes literally 2 to 3 minutes because, again, you're not installing an OS, right? You're just copying an image and letting that run on top of your hypervisor. And then this host partition now is going to partition your guest role, and then it's going to install the Fabric or the .NET runtime and the Win32 runtime on top of it. And finally, the CS package file that we uploaded gets pulled in here and starts running. So this entire process takes about 5 minutes to 10 minutes or so, depending on the load up there. And so what you'll actually see is when that happens, you see how it's saying initializing now? From initializing, it's going to change to busy, and from busy, it's going to change to running. And at that point, if you hit this URL, you will see that same application pop up on a browser. So with that, I'm going to wrap up because I've already exceeded. So thank you so much for your patience. And if you have any questions, do I have time for questions?
Sure.
Okay, if you have any questions, I'll take a few until we get thrown out. Sorry.
Is there any way that the application can negotiate parameters such as survivability, continuity of service with the platform? I mean, and having guaranteed that the platform honor that.
Oh, so you're saying can the application request a certain level of availability
before being deployed? Can they negotiate? Can it negotiate some?
Right. So we publish a certain, I think it's 3 nines or something. We publish a certain level of availability.
Yeah.
And so the app cannot negotiate that actually. So, but that's something we will honor, absolutely. And the app can absolutely expect that. And the thing that we also say is we always say create 2 roles in case one goes down, then the other can come in those 0.005 cases where, calamity does occur with your app or with the hardware. Yes.
So the geographical location of where it's actually run, can I define it somewhere or pre-negotiate?
Absolutely. So when we set up the service instance, we basically chose a geolocation. So you can absolutely say, I need this running, but the granularity that you're requesting can only extend as far as the data center. So inside the data center, we'll not be able to say, give me rack 3 or something. You can say, take these 3 or 4 different roles or these storage projects and co-locate them. And that's what we mean when we say affinity roles. And what it's going to try and do is going to try and co-locate them as close as physically possible. Sometimes maybe giving it the same rack even, so that they're as close to each other as possible. But again, that's not something that we have any direct control over.
But will that be a service later on? Because some has more security concerns, want to have their own server and this kind of things.
Oh, like a VPN, a virtual private server kind of scenario, like maybe...
Actually on the same hardware, not doing multi-tenancy at all, with others.
Right. You could, the only way to do that is if you took up 8 rows, if you took an extra large VM size, you will get all 8 cores on that wafer, on that motherboard. So that's the only way I can think of. Yeah. To have nobody else running on it. Yep. Oh, the mic.
Price difference in different affinities?
Yes. So the question was, is there a price difference between the different role sizes, right?
Right.
So for
not role sizes, but
for the affinity groups and such.
Right.
No, not at all.
So why would you ever say no? I don't want them close together.
You wouldn't actually. Most often. So here's the reason why you might not say that. If you basically have a whole bunch of instances and you say, I want them all as part of this affinity group, maybe we're not able to do it. Maybe we'll come back and say, sorry, no availability in the group that you've requested. At that point, you can probably say, oh, I don't care now, break it up, but just give me some allocation. So that's probably the only reason why you'd choose that. But other than that, you'll probably always want the same affinity group. So with that,
one last question.
One last question.
Thank you. You created 5 instances, and we are using only 1. When the others come in the game?
Oh, all of the instances are up and running.
Yeah.
So if I had some diagnostic that I was throwing out saying, so you can actually do that, right? You can basically, in my application, I could have written some code that throws out the name of the machine on which it's running, for instance. Then you'll actually see, if you hit it from 5 different machines, you'll actually see 5 different. So if the 5 of you in your row hit the service, each of you would see a different machine name on your browser.
But you can define a threshold for the workload for each instance.
Can you define the address for
a threshold?
A threshold for each instance, like. No, it's just symmetric load balancing. So it's just gonna, with the it's a hardware load balancer that does symmetric. So it does have some affinity. So if you basically go to the site and you come back to that same site from that same browser, it'll try and give you the same node, because if you have any session state temporarily saved, it'll allow you to take advantage of it. But you cannot be guaranteed that it's going to go back to the same instance. It'll try and load balance across all instances evenly. Absolutely.
Thank you.
All right, so thank you so much, people, and it was...
Let's give Krishna a round of applause.
Thank you.